Welcome to the channel. Decode the complex. Master your code.
Hello everyone, welcome back to my channel. This is Deepak Kumar, and today we are going to discuss question number 3761. Now today's question is complete prime number. Now here in this question we are given an integer number. Now we have to check if all the prefixes and suffixes of that number is a prime number. If it is, then we have to return true, and if it is not, then we have to return false. Now let's see what a suffix and prefix here is and how we are going to tackle the question. I'm going to skip all the examples here and let's understand it with some other examples first. Now here I'm going to take an example of number 97. Now this number is a prime number. Here in this number, my first prefix will be 9 and second prefix will be 97. And if I'm talking about suffix, then it will be 7, then 97. And if it were numbers like 197, something like this, then my prefix might be 1, then 19, then 197, then the number 1973. And prefix will might be something like 373, 973, and 1973. And now we have to check if each number is a prime number or not. So what we are going to do is to make each number, make each suffix and each prefix once at a time, and we will check if the number is prime number or not. If there is any, then we will return false, and if there isn't any, then we will return true. Now we are going to use some of the mathematics here to calculate or to resolve our issue. Like if the number is less than 2, then we will return false because the number won't be prime. It will be a unique number which is 1 or 0. Like in some cases, like 190, the suffix will be 0 at one time. Now if the number is 2, n equals 2 at some point, like 291, here prefix will be 2 in start, uh, then we will return true for the prime here directly. But if the number n is divisible by 2, then what we will do here is to return false again for the prime, because the number when is divisible by 2 and isn't 2, then it will be an even number and which won't be a prime number. So let's move back to our code and we'll see what we are going to do there. So here we are. Now let's write the code. So first we will make a function to check prime. Here, if my number is less than 2, then we will directly return false. If my number is equals to 2, then we will return true. And if my number is divisible by 2, then we will again return false. Now you might think that if I pass n equals to 2, then sorry, then it might return false as n% 2 equals 0. But not, but it won't be the case because at this point it will return true and the rest of the code won't work. Now let's start our for loop, and I will here start from 3 because we have already taken care of number till 2. And here we are. Now I am taking here I into I should be less than or equal to n, which means if a number is a perfect square like 36, or let's say 4. I'm using I into I less than or equals to n. It is especially for square root because if a number isn't divisible till its square root part, then it won't be divisible after that. For example, if a number is divisible by 5, for example, here case 25, which is where 5 is the square root. So before that 5, we have exactly one factor of 25, which is 1, and exactly one factor after 5, which is 25 itself, as a factor of 25. And it is true for all the natural numbers present in the universe. It might, even if we are talking about 10, then its square root lies around 3 and 4. So the number of factors before 3 point something that which is square root, and after that will be same. There is 1 and 2 before 3.3, and after that 5 and 10 itself. So now moving on to code. Here if I'm checking, if my n is divisible by I, if it is 0, then I'm going to return false, and if it didn't, then I'm going to return true. Now here, let's declare a few numbers first. Here is a suffix, here is a prefix, and here is a traveling point. Now, one more thing. As you know, it is the we are given a number as an input, so we can't travel freely from the starting and from the end both. So what I'm going to do is to convert the number into string. Now I can travel from start as well as from end. Now here I'm going to store the endpoint of the string. Now let's start our while loop. Here we will make sure we are less than n, as I will be an index. Now x, what the x will be exactly? X will be x into 10 plus ss of I of an odd index minus 0 as a character. Now this one gives you the exact number of at that present index, which was a character. Something like if the character was 7, if I subtract 0, then from ASCII value, it will become 7. And what I'm doing here is x equals x into 10, which means, for example, if my number was 23, then at start will be 0. So 0 into 10 plus 2, which will be 2. Then at next point, x equals to 2 will be there. 2 into 10 plus 3, 23, which will be my next sorry, next prefix. And now let's talk about our suffix. Now for suffix part, what here we will do, what here we will do is to operate at the last index. Here at I equals to 0, we will be tracking at the last index. For example, at 23, the last index will be 1, and since the length is 2, so length minus 2 minus 0 minus 1, which is 1. Here we will give power of 10 and I plus suffix value. Now here, what we are doing is to keep the position of the number safe. For example, in number 1567, first we had 7 at last position. Then while adding 6, what we are going to do is here to get 6, then multiplying it by 10 to the power I, which is here will be 1. Then we will be adding suffix, which was 7 earlier, making it 67. And this loop will go to 567 in the next round and then 1567 in the next year. Now what we are going to do is to call a function isPrime here. And now let's call the prefix function. And now we will check if any of the numbers is false, as if the number might not be a complete prime after any of the prefix or suffix become a composite number or a unique number. And now we will increment the I so that the numbers won't stuck at one place forever. Now, if the loop has been gone through for all the indexes and there is no any universal number which is 1 or any composite number found, then we will can return true. So now let's try the test cases here. As you can see, all the test cases here have been cleared. So let's add some of our own. Now let's try these test cases. As you can see, all the test cases I have added has been cleared. So now let's submit the code. As you can see, all the test cases here have been cleared. In this approach, my space complexity is O of k, where k is the length of digits of or length of number m num, and my time complexity here will be k into log of n. Now this is all for today. I hope you like the approach. If you like, then like the video, subscribe the channel, comment down your thoughts.